Okay, buckle up. We got a bit of a long one here, so take a deep breath. Okay, we're ready. So this lesson is on polynomials, get it? And Pascal's triangle. Now there is a blank Pascal's triangle I have in D2L under the content section for this unit. If you have a printer, you can print it off and fill in, when we get to Pascal's triangle, fill it in that blank one. Or it works just as easy to fill it in in your note just using the numbers. And that'll make more sense once we get to the second half of the lesson. Our learning goals, we have 3 of them. Review, FOIL, binomial expansion. We're going to apply that to multiplying higher order polynomials. And then we're going to do binomial expansion using Pascal's triangle. Starting off nice and easy. A question you could have done in grade 10, expand and simplify. You can use the acronym FOIL if you want. So first times first. I like to draw the arrows to just help guide my eyes what to do and make sure I don't forget any terms. 2x times 3x gives us 6x squared. Outside, 2x times negative 5, negative 10x. Negative 1 times 3x inside, negative 3x. And last times last, negative 1 times negative 5 is positive 5. Collect like terms, almost always they'll be in the middle. Negative 10x minus 3x is negative 13x plus 5. Done. Whether or not you use the acronym FOIL doesn't really matter. All that matters is that everything in one bracket has to be multiplied by every term in the second set of brackets. That's all that it boils down to. And we're going to build on that for doing higher order polynomials, such as this one. So our first real example, expand and simplify. If you want to come up with another acronym for this, you can. We obviously can't use FOIL because there's going to be more than 4 terms, but we want to borrow the main idea, the philosophy. Everything in the first bracket times everything in the second bracket. X times x squared, x cubed. X times negative 2x, negative 2x squared. X times negative 9, negative 9x. 5 times x squared, 5x squared. 5 times negative 2x, negative 10x. 5 times negative 9, negative 45. Collecting like terms. Sometimes it helps to use a highlighter or a different color. And then you can cross things out or highlight them. That way they kind of stand out to you. X cubed, there are no other x cubes. X squareds, I got 1 here, so negative 2x squared plus 5x squared gives me 3x squareds. Negative 9x minus 10x, negative 19x. And then negative 45, there's no other constant terms, we're done. If by chance you aren't given in the question the terms in descending order of x, so from highest exponent to lowest, make sure when you make your final solution and you've collected like terms that you arrange them in descending order of x, meaning the highest exponent on x down to the lowest exponent on x, going all the way down to our constant term. Okay, kicking it up another notch. Now we're doing 3 by 3. So it's not hard, just organization is super important here. Here we go. X squared times 4x squared gives me 4x to the 4. X squared times negative 3x gives me negative 3x cubed. X squared times 10x, 10x squared. Now I'm going to color code this. You don't have to color code it, but I'm going to just to make it stand out a little bit. Now 3x times everything in the other bracket. 3x times 4x squared gives us 12x cubed. 3x times negative 3x gives me negative 9x squared. 3x times 10, 30x. 2/3 of the way there. And we'll use purple. Negative 1 times 4x squared, negative 4x squared. Negative 1 times negative 3x, positive 3x. Negative 1 times 10, negative 10. So we ended up with 9 terms. Let's use, we'll use blue. So collecting like terms, 4x to the 4. That's the only x to the 4 term I have. X cubes, I got a negative 3x cubed there and a negative 9x cubed there. And I've got a 12, oops, we made a mistake. So I must have heard some of you screaming at me at home on my typo. If that was you, awesome. I'm just going to erase this. So that shouldn't have been negative 9x cubed. That should have been negative 9x squared. And if you caught that, good on you. Good thing we caught it before it was too late. Okay, going back to our x cubes. Negative 3x cubed plus 12x cubed gives us 9x cubed. Square terms, I have 10 of them, minus 9 of them, minus 4 of them. 10 minus 9 is 1, minus 4 is negative 3x cubed, squared. Don't know why I keep wanting to say cubed. 30x plus 3x gives me 33x, and then my constant term minus 10. Okay, we did it. C. This is going to be our biggest one yet. So I have a squared, and I have a coefficient of 2 out front. One thing you definitely won't do, it'd be like a kitten-killing mistake. Don't distribute the 2 into the brackets first. You have to follow Bedmas, which means you have to do the exponent first. How do I take care of that squared? Well, what does squaring something mean? Something times itself. So 2 a plus 2b plus 3c times itself. What you do next is up to you. You can distribute the 2 into just the first bracket if you want to do that first. Then you could do your distributed property or your expansion. Or you could do your expansion first and then multiply the 2 in. Me, I'm personally someone that likes to do the expansion first. If you're not like that, again, 2 ways to skin a cat, so to speak. So you can multiply the 2 in and you'll get the same answer as us. But I'm going to save the 2 till the very end. Okay, here we go. So 2. A times a squared. A times 2b. 2ab. A times 3c, 3ac. 2b times a, 2ab. 2b times 2b, 4b squared. 2b times 3c, 6bc. Don't forget the plus. We okay so far? And you'll notice too when I'm doing these, regardless of the order of letters, I'm putting them in from like the alphabet, like alphabetizing them from A to Z. And if you do that, then you don't have to worry about like, is an AB the same thing as a BA? Which the answer is yes, but at least there'll never be those questions asked. And then last but not least, we've got to multiply that 3c by everything. 3c times a, 3ac. 3c times 2b, 6bc. And then we have 3c times 3c is 9c squared. So probably this is going across your whole page. And depending how big you wrote, you might have even had to go to another page. Let's collect like terms first before we distribute that 2 in. A squared. I don't have any more of those. I have a 2ab, and a 2ab gives me 4ab. AC, I have 3, and 3 gives me 6 ACs. No other b squareds. 6bc and 6bc gives me 12 bc's, and then 9c squared. So we're able to make it quite a bit smaller. Now let's distribute that 2 in. 2 times a, 2a squared. 2 times 4ab, 8ab. 2 times 6ac, 12ac. 2 times 4b squared, 8b squared. 2 times 12bc, 24bc. 2 times 9c squared, 18c squared. Now, technically speaking, there's no real rule for like writing all of these in descending order of powers. So I'm going to leave it like that. If you want to write it 2a squared plus 8b squared plus 18c squared plus 8ab plus 12ac plus 24bc, you are more than welcome to. But since there are more than one variable in our terms, it doesn't really matter. You can leave it like that. So how do we feel about that? Hopefully you're nodding your head, maybe side to side, kind of like, it's not too bad. Not great, not too bad, hopefully. Okay, we're going to try these. Now, typically in class, this would be kind of like a warm-up activity. And, you would go through the expansion like we just did, and it would be incredibly time consuming. So for now, I'm going to say, don't bother copying this. If you did, I'm just going to spit back the final answers to you because there is a discernible pattern here. A plus b to the 0, how do you expand that? That's a good question. You don't. But we do know anything to the power of 0 is, don't say 0, hopefully you shut it out, 1. Okay. A plus b to the power of 1. How do you expand that? You don't. It's just one of them, a plus b. A plus b squared. If you expanded this, you would get a squared plus 2ab plus b squared. Cubed, if you expanded it. And again, don't worry about where these are coming from. This would just you be doing it long ways. But we're going to come up with an easier way. So you would get a cubed plus 3a squared b plus 3ab squared. plus b cubed. A plus b to the power of 4. This is typically where students start to cry when they're doing this the long way. A to the 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the 4. And then once they get to a plus b to the 5, they give up and say things like, makes my eyes hurt. So I'm going to write, makes my eyes bleed. Ugh. So how do we come up with those? The first 3 are easy. Even a plus b cubed's not terrible. But then as soon as we get up to the exponents 4, 5, and above, it's really time consuming. It takes up more than one line of your page. Is there an easier way? The answer is yes. We have Pascal's triangle to the rescue. Now, you don't have to draw all those honeycombs. That's just what I've placed as a blank one in D2L. All that matters is you just kind of make the number pattern in a pyramid shape that I'm about to do. And we'll see if anybody picks up on the pattern. So 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. I'm going to stop. Does anybody see a pattern? It's okay if you don't, because I'm about to tell you. So Pascal's triangle. The first 3 numbers in the pyramid are always 1. The numbers on the outside, as you go down on a diagonal on the left and right side of your pyramid, are also only 1. And even though there's nothing written there, all around that pyramid, there's just a bunch of zeros. Okay, so we know the first 3 entries in our pyramid have to be 1. 1, 1, 1. How did I get 1, 2, 1, and then 1, 3, 3, 1? Well, these 2 numbers add to that number. And on the outside, there's always 1s. How did I get 3? 1 plus 2. How did I get 3? 2 plus 1. How did I get 4? 1 plus 3. How did I get 6? 3 plus 3. How did I get 4? 3 plus 1. Does that make sense? See if you can, in a second, pause it and come up with the next 3 rows on your own. Hopefully you took me up on my relatively easy challenge now that we know the pattern, and my next row should be 1, 5, 10, 10, 5, 1. Next row, 1, 6, 15, 20, 15, 6, and 1. 1, 7, 21, 35, 35, 21, 7, and 1. Now, if you're wondering, how does this relate to expansion, and specifically binomial expansion? Each one of these rows, we can give them a row number. So we're going to say this is row 0, row 1, 2, 3, 4, 5, 6, and 7. And by the way, this doesn't end at 7. This goes on infinitely. Take a look at the last slide, or rewind a bit, or just think about it. When my exponent was 0, what was my answer? 1. That's the top of my pyramid. When my exponent was 1, what did I end up with? 1a and 1b, and I have 1 and 1. When I squared a plus b, what did I end up with? I ended up with an a squared, 2ab, and a b squared. 1, 2, 1. This actually gives us the coefficients of the binomial expansion. And then there's a little bit of patterning we do with the exponents that's going to eliminate any of your need to come up with doing any distribution when you get to higher powers like 3, 4, 5, 6, 7. And even though I didn't go to row 8 or 9 or 10, you could add row 8 right now. You could add row 9 after that. You could add row 10. But the important piece here is R, in this case for Pascal's triangle, is the row number. This equals or corresponds to the exponent in binomial expansion. So our general format using Pascal's triangle, I'm just going to do it generally here, which is going to make it look pretty crazy. But once we do some examples, you'll see it. So if we have a binomial, and again, this only works for binomial expansion, meaning two terms to some exponent. So if we have a plus b to some exponent r, this equals c1 a to the r b to the 0. And again, don't worry about the letters. I'll talk about them in a second. This is just giving you the general formula. C2, a to the r minus 1, b to the 1, plus C3, a to the r minus 2, then b squared, plus dot dot dot, plus Cn a to the 0, b to the r. What are all those c's? All of those c's, C1, C2, C3, all the way to Cn, are the coefficients which correspond to the row number, which is R, of Pascal's triangle. So C1, C2, C3, they're just the rows in Pascal's triangle. So 1, 1, 1, 2, 1, 1, 3, 3, 1, and so on. Now let's talk about what's going on with the A and the B. Well, our first term is always going to be A to our exponent R, and each subsequent term, the exponent is going to be one less than the previous. B is the opposite. Our first term is b to the 0, which is just 1, and each subsequent term, b1, b2, all the way to br, is just increasing the exponent on b. So a is going to start at the exponent and go down by 1 every single term. B is going to start at 0 and go up by 1 until you hit r. Let's do some practice. And make sure you have Pascal's triangle in front of you. So we're going to stop making our eyes bleed, and we're going to try a plus b to the power 5 for reals. So r equals 5, which means you're looking at row 5 of Pascal's triangle, which means our coefficients are going to be, now you're looking at it, I'm just going to write it down so you know where the numbers are coming from. 1, 5, 10, 10, 5, and 1. Using our pattern, okay, the first number gives us our coefficient. There's our first term, 1. So this equals 1. A to the r is 5. Now you can write b to the 0, but b to the 0 is just 1, and 1 times anything isn't going to change it. So let's not add more visual clutter. plus, what's my next coefficient? 5, getting that from my next number in Pascal's triangle. The exponent on A goes down by 1. The exponent on B goes up by 1. So A to the 4, B to the 1. My next term, coefficient is 10. A goes down, B goes up. Next coefficient, 10. A goes down, B goes up. Plus, next coefficient. A goes down, B goes up. Last term, 1. A goes down, A to the 0. You don't have to bother writing that because that's just 1. B to the 5. How was that? That sure beat writing A plus 5 in brackets 5 times and going through all that expansion. It definitely would have made your eyes bleed. As a built-in self-check, all of those terms, what do the exponents add up to? 5. Term 1, 5. Term 2, 4 plus 1, 5. Term 3, 3 plus 2, 5. Term 4, 2 plus 3, 5. Term 5, 1 plus 4, 5. Term 6, b to the 5 is 5. If those don't add up to your exponent, to your r value, you have made a mistake. All right, now that I feel like, I hope, we get an idea of what we're doing, we are going to kick it up a notch. First thing, you might want to identify what a and b are. So 2 to the x, that is your entire, or 2x is your entire a term. Y, that is your entire b term. Your r value is 7. So we are going to go to row 7 of Pascal's triangle, which gives us 1, 7, 21, 35, 35, 21, 7, 1. This is probably going to go beyond one line across your page, unfortunately. So organization is going to be key here. So we have a 1, first term coefficient. Then 2 to the x is my a value. And you're going to notice I wrote it in brackets because 2x is the entire a to the 7. Plus, next coefficient, 7. 2 to the x to the 6, y to the 1. Next coefficient, 21. 2x, exponent goes down by 1, 5. B goes up by 1, 2. Plus 35. 2x to the power 4, y cubed. Again, those always have to add to 7. Next coefficient, 35 again. 2x cubed, y to the 4. I'm going to continue down here. Plus. Next coefficient, 21. 2x squared, y to the 5. Next coefficient, 7. 2x to the 1, y to the 6, and last but not least, 1y to the 7. Okay. We have further simplifying to do here. It's going to be important to pay attention here. When we look at term number 1, that 7 doesn't just go to the x, it goes to the 2. Also, so you have to do 2 to the power of 7. What is 2 to the power of 7? It is 1024. Times my coefficient 1 is just 1024. X to the power of 7. Done. I'm going to check them off as I do them. The next term, 2 to the power of 6. Okay, so we're going to do 2 to the power of 6, which is Hold on, I think we made a mistake here. We're going to go back for a second. Got ahead of myself. 2 to the power 7 is not 1024. It is 128 times 1. It is 128 x to the power of 7. Now we're on the right track. 2 to the power of 6 is 64 times the coefficient 7. 448 x to the 6 y. Third term, 2 to the 5 is 32. Times are my coefficient, times 21. 672. X to the 5, y squared. Next term, 2 to the power of 4 is 16. 16 times 35 is 560. X to the 4, y cubed. 2 cubed is 8. 8 times 35, 280. X cubed, y to the 4. I'm going to continue down here. Plus 2 squared is 4. 4 times 21 is 84. X squared, y to the power of 5. So we did that term already. We just did that term. Now we're here. 2 to the power of 1 is 2 times 7 is 14. And that would be x, y to the 6. And lastly, we have just y to the power of 7. So that was definitely a page full, a mouthful, and a calculator full. But as long as you stay organized and kind of go step by step and go slow when you do this on your own, at least the first few times you do it, it's not too bad, hopefully. Our next one. So we're kicking this up another notch. Not only do we have not just like x and b or a and b, we have 4x, so this whole thing is my a. We now have a negative and an exponent. So that negative b squared is actually your b value. And what that's going to do is that's going to make our terms flip-flop between positive and negatives. Our r value, 5. Look at row 5. That means you're going to have coefficients of 1, 5, 10, 10, 5, and 1. Okay, so take a deep breath, crack our knuckles. Here we go. 4x to the 5 plus my next coefficient, which if you realize I didn't write the 1, I guess I will, but it's not going to affect anything. My next coefficient, 5. 4x goes down by 1, so 4, and then negative b squared to the power of 1. Next coefficient, 10. 4x goes down by 1. Negative b squared goes up by 1. Next coefficient, 10. 4x goes down by 1. Negative b squared goes up by 1. Continue down here. Plus my next coefficient, 5. 4x goes down by 1. Negative b squared goes up by 1. Plus last coefficient. And we have negative b squared. Sorry, I know that looks like a 4. We'll erase that. Negative b squared and to the power 5. So we're going to tackle these one at a time. First term, 5 to the power of 4, 1024, x to the 5. Next one. Okay, so we got to pay attention here. 4 to the power of 4. So 4 to the power of 4 is 256 times 5, 1280, okay? But I also have this negative coefficient right here in front of the b, and that negative b to the 1 is still going to be negative. So this is actually going to be negative 1280 x to the 4 b squared. So you want me to say that again, I'll say it again. First thing we gotta do, 4 to the power of 4. 4 to the power of 4. 256 times my 5 coefficient times 5, 1280. I have a coefficient now in front of that b. It's a negative, and negative to the power of 1 still negative, so it becomes negative 1280. My next term, plus 4 cubed is 64 times 10, 640. Now if we look at this negative, negative squared, right, from our exponent is a positive, so that's how I know it's plus. Plus 640 x cubed. Now one thing you're going to have to be careful, when your a or b has some exponent on them, they're not always going to add up to r. You have to go back to your power law. And power law, right, power, power, exponent, exponent, you multiply. 2 times 2 is 4. So this is x cubed b to the power of 4. Next term, 4 squared is 16 times 10 is 160. That negative cubed is going to be negative, so that's going to be negative 160. As you can see, the pattern that is evolving, positive, negative, positive, negative, they're just going to flip-flop. X squared, and then 2 times 3 is 6, b to the 6. Next term, 4 to the power of 1 is 4 times 5 is 20. A negative to a positive exponent is going to be positive, so this is just plus 20. X, and then 2 times 4, power law, b to the power of 8. Last but not least, a negative to a odd exponent is negative. That will be negative b to the 10. Whew. So that was the toughest one yet, or at least we had to pay the most attention to the details. Again, once you practice these on your own, they should be okay, hopefully. And if not, remember I'm here to help. Our last example, expand and simplify, but instead of doing that whole thing, I'm just going to say, what is the third term in 2x plus 5 to the 8? So I'm just going to ask you for a specific term. So it isn't as bad. All right, what's my r value? My r value is 8. Well, we don't have row 8 in our Pascal's triangle. Maybe take a second right now and throw row 8 on there. And when you do, you should get 1, 8, 28, 56, blah, blah, blah. I want the third term. What is my third term? Right there, 28. So that means my coefficient is going to be, so the third term equals 28. This is my a value. This is my b value. So 2x. Now you kind of have to do some deductive reasoning here, or maybe thinking out loud. So the first term would have an exponent of 8. The second term, right, goes down by 1, would have an exponent of 7. Third term goes down by 1, would have an exponent of 6. 5 That's my b term. Again, we're going to think about this out loud. On the first term, the b isn't there. It has an exponent of 0. On the second term, goes up by 1, so it has an exponent of 1. On the third term, goes up by 1, has an exponent of 2. And again, 6 plus 2 is 8. Reasonably good self-check. And maybe I'll write some more steps for this one. This would be 28, right? Then 2 to the power of 6 is 64, x to the 6. 5 squared is 25. From there, you just multiply all your coefficients. 28 times 64 times 25. Whoa, 44,800 x to the power of 6 is our third term. I couldn't imagine doing binomial expansion the long way without Pascal's triangle, or at least the patterns to help guide us. Okay, we did it. And hopefully that did not turn your brain into stew. Worksheet 3.3 and 3.4. There's only 2 more lessons, and then you're going to have your test on Wednesday, roughly mid-morning. That's it. Thanks for listening. Happy mathing.